Hello everyone, welcome to my channel. So this is the last part of the chapter heat. In the previous part we have seen in activity 6 that black bodies absorb heat faster in compared to white bodies. Here we will see about radiation. So let's see. To show that the black bodies are better heat radiators than the white bodies. So material required are the same like the previous activity. 2 cans, thermometer and black and white paints. Procedure: take 2 cans used in activity previously or previous activity. Pour equal volume of hot water at about 70 degree Celsius into these cans. So in the previous experiment we have seen this, right? So let's take again the same 100 ml, 100 ml in both the cans and 70 degree Celsius and 70 degree Celsius temperature. Insert a thermometer in each of them like the previous experiment. Place both the cans in shade for about half an hour and then read temperature of water in both the cans. So what we will do? We will keep the setup in shade for half an hour. Then we will see the observation. So what is the observation? See. Temperature of water in black can is lowered than that of white can. So what is the reason behind it? Definitely heat has been radiated. So the conclusion is this shows that black bodies give out or radiate heat faster than white bodies, because the temperature scale was showing that the lowering in temperature from 70 degrees Celsius, okay, in both the cans, but in white can the temperature, the drop in temperature was less in compared to black. So it says that black bodies give out or radiate heat faster than white bodies. Now, similarly, a bright, shiny surface is a poor absorber of heat radiation because it reflects the radiation falling on it. Now, what does this mean? Let's see by an example. An electric room heater. An electric room heater is provided with a curved, polished metal reflector behind the heating element. So as you can see this picture, this is the heating element. And how we can heat this? By the electricity supply. When we switch on the electricity supply, then this electrical energy is converted to heat energy and this produces the heat. Now this polished surface reflects back all the heat radiation falling on it towards the person sitting in front of the room heater. So this is the curved polished surface. See, it is marked. This is the polished surface. So what happens? The heat that is radiated at back, definitely the heat that is radiated at front that we are getting, but the heat radiated at back gets reflected at this polished surface and it comes to us. So this polished surface reflects back all the heat radiation falling on it towards the person sitting in the front of the room heater. The inner walls of a thermos flask also have polished reflecting surfaces so that they absorb little heat and reflect most of it. So we all know about this. This is very common thing. So if this is a thermos flask, when we keep hot water or hot tea inside this, it remains hot for long hours or long time. Why? Because inside this reflecting surface is present. So when the heat tries to go out, it reflects back and get inside this thermos flask. That's why the content or the hot content inside this thermos flask remain intact for long hours. Nowadays, many kitchen utensils are made of black color because such utensils absorb more heat and cookings become faster. Okay, the backside of that of the cooking utensils are made of black color so that it can definitely absorb more heat and the cooking becomes faster. So kinds of clothes we wear in summer and winter. We wear white or light colored clothes during summer but dark colored during winter. Let's see the reason. This is because white or light colored cloths absorb lesser heat and keep us cool during summer. Very true, because we have seen in the activity also that white colored can was absorbing less heat in compared to the black colored can. So on the other hand, black or dark colored cloths absorb more heat and keep us warm during winter. So this is the reason. We also use woolen cloths during winter. So now let's see the reason behind this. Woolen cloths keep us warm. Why? Wool is a poor conductor of heat and it has air trapped between the fibers. So here the two importance of the woolen cloths is been mentioned, or the wool is mentioned. That is, wool is poor conductor of heat. Moreover, it has trapped spaces between them. It has spaces between them which can trap the air. This air prevents the heat of our body to flow outside. Thus, we feel warm. So this is a very important question. Why we wear woolen cloths? This can come in your exam also. This is also the reason that two thin woolen blankets provide more warmth than one thick blanket. Why? It is because two blankets have a layer of air between them. Since air is an insulator, its layer prevents the heat to flow. Very simple. Instead of one blanket, if we take two blankets, the air will be more trapped inside and it will keep us warm because air is an insulator. Fast fact. The color of an object is the light it reflects. An object is white if it reflects all or almost all of the light falling on it. An object is black if it reflects no or very little light. And since light is a form of energy, absorbing a lot of light means increase in energy and so a larger increase in heat. So let's understand this one by one. The color of any object is the light it reflects. Suppose this is a surface of an object and this is red in color. So how we see this red color? When white light, or suppose the light from the sun, when falls on it, actually we all know that white light consists of 7 colors. So from these 7 colors, except one color, that is red, all the other 6 colors are absorbed by this object or the surface. And the red color which is getting reflected comes to our eye and we see the object as red color. So the color of an object is the light it reflects. So as the object is reflecting only the red light, that's why we can see the object as red color and it is absorbing all the other colors. An object is white if it reflects all or almost all the light falling on it. Now let's consider another surface of an object. Suppose this is white. So when white light falls on this object, it actually reflects all the light. That means when white light falls on this object, it do not absorb any of the light, rather it reflects the entire white light. That's why we see the object as white. Now an object is black if it reflects no or very little light. The third case, suppose this is an object surface, this is black colored. Why we see black color? When white light falls on it, all the colors that are in white light gets absorbed. Or precisely to say, this entire white light gets absorbed by this object and no reflection of the light occurs. That's why we see the object as black. And since light is a form of energy, absorbing a lot of light means increase in energy and so a larger increase in heat. So as we all know that light is a form of energy. So when this light falls on an object, definitely light is getting absorbed, which directly increase the heat. Now, comparison between conduction, convection and radiation. Feature: heat transfer. Conduction. The heat energy is transferred from one particle to another particles of a medium without the particles leaving their places. As we have discussed in case of the copper rod, when we take the Bunsen burner at its one end, the heat is getting conveyed to the last end by this process. So here one particle to another particle of a medium without the particle leaving their place. So definitely the particle movement is not possible here, because in solid there is no particle movement can be seen. So how the heat can be transferred? By this conduction. Convection. Particles of medium move away from the source of heat after absorbing heat from the source. Practical example: boiling water or water boiling in a beaker or a container. This water molecules or these water particles from this bottom of the beaker or bottom of the container gets heated up, and after they get the heat, these particles go up and the cold particles come down. So this is a convection process that we have discussed in the chapter. Now, radiation. Heat energy is transmitted in the form of electromagnetic waves. Suppose this is the light, this is the heat source, and a person is sitting here. So this will be by the electromagnetic waves, that is in the form of wave. Need of medium. Needs a medium does not takes place if no intervening medium is present. So definitely in case of this copper rod, if a gap is here, and this copper wire is or copper rod is broken, will the heat come from this side to this side? No. So definitely medium is required. Convection. Needs a medium does not takes place if medium is not present. Similarly, in case of this boiling water also, if other molecules are not present, how will this molecule at the bottom or the particle will go up? So it also needs the medium. Radiation does not need any material medium. So the material of the medium does not matter, because it can travel through vacuum also. Now, change in temperature. There is a change in temperature of the medium. In case of conduction, change in temperature is seen. Why? Because copper rod, when we are heating the copper rod, heat is being absorbed by the copper rod. So definitely change in temperature will be there, that is temperature is rising. Now in case of convection, temperature of the medium changes. When we are boiling the water, at first initially it was at room temperature. Now when we start boiling and it gets boiled, it attains 100 degrees Celsius. So here also change in temperature is there. The temperature of the medium does not change. Let's take the example as we have seen. Suppose this is the heat source and a person is sitting here, and as soon as we sit beside this fireplace, we feel the heat due to the radiation process, and the medium between these two is air. So air is a poor conductor of heat. So medium temperature does not change. Now, movement of heat takes place in all directions, definitely. In case of convection, heat moves towards cooler region. How? So in case of this water, when we heat by using any heat supply like Bunsen burner, the water gets heated up at the bottom, but the water is cooler at the top. So the water particles or the molecules gets raised up, or they rise up from the hotter region to the cooler region. In case of radiation, takes place in all directions, and a special case is here. In vacuum, thermal radiation, that is heat transfer or the heat energy radiation, travel with velocity of light, transferring heat energy at a faster rate. So as we all know that the velocity means speed here only. The speed of light is 3 into 10 to the power 8 meter per second. So When vacuum is present, the heat radiation from the source to an object or to any place occurs by the speed of light, or the heat radiation travels in vacuum with the speed of light. That is, it transfers heat energy at faster rate. So this was it. So thank you, like, comment and subscribe the channel.